Good morning all. Myself Ramya, working as Assistant Professor in the Department of ECE, Hindustan College of Engineering and Technology, Coimbatore. Now I am going to discuss about angle modulation, which comes under the subject of analog communication, the subject code of 16 EC 5201. Angle modulation is defined as a process by which frequency or phase of the high frequency carrier signal is varied in accordance with the instantaneous amplitude of the modulating signal. There are two types of angle modulation, which can be frequency modulation and phase modulation. Frequency modulation means that the frequency of the carrier is varied in accordance with the instantaneous amplitude of the message signal. Phase modulation is the process by which the phase of the carrier is varied in accordance with the instantaneous amplitude of the message signal. Whereas in both the cases, amplitude is maintained constant. The carrier wave's amplitude is maintained constant. The applications of frequency modulation is radio broadcasting, two-way mobile radio, microwave communications, TV audio transmissions, cellular communications and satellite communication. The main advantage of this angle modulation is noise reduction and efficient usage of power, whereas disadvantages is more bandwidth. That is, bandwidth will be more occupied by means of this angle modulation system. And frequency modulation, we will see in detail about frequency modulation, where the frequency of the carrier is varied according to the instantaneous value of the message signal. When the instantaneous value is 0, frequency will be same as Fc. When the instantaneous value increases, frequency of the carrier also increases. When the instantaneous value is maximum, frequency will be maximum with the maximum deviation of del f, Fc plus del f. When the instantaneous value decreases, frequency also decreases, and when the instantaneous value reaches minimum value, frequency also reaches a minimum value with the frequency deviation of del f, so Fc minus del f. This shows the frequency modulation concept. So, this is the message signal, this is the carrier signal. Depending upon the amplitude, carrier signal's frequency has to be varied. So, when frequency increases, message signals carrier signals frequency also increases. When the message signals amplitude decreases, carrier's frequency also decreases. This shows a frequency modulated signal. Frequency modulation is developed based on the scheme involved here. So, when amplitude of the message increases, frequency of the carrier increases. When the amplitude of the message decreases, frequency of the carrier decreases. So, main advantage is that the power which are utilized in frequency modulation is useful. Whereas in modulation, you have the carrier component which is useless is also transmitted, that is avoided here, and adjacent channel interference is also avoided here, and signal to noise ratio will be very high. Drawback is wider bandwidth. And various applications are there for frequency modulation particularly, and these are the applications of frequency modulation. And for mathematical representation of FM, this is a message signal which is given by small em is equal to capital M cos omega mt, where capital M is the maximum amplitude and omega m is the angular frequency of the message signal. And this is the carrier which is given by EC equal to capital EC sin omega ct plus theta, where omega c is the angular frequency and theta is the phase angle. And here this is angle modulation. So, we have to concentrate on the frequency modulation. So, angular frequency is taken omega c equal to d phi by dt. After frequency modulation, this angular frequency of the carrier is varied in accordance with the instantaneous value of the message signal. So, instantaneous value of the FM wave, frequency modulated wave omega I is omega c plus k Em. Em is instantaneous value of the message, which is Em cos omega mt. So, omega I is equal to omega c plus or minus k Em. From this, we are finding del f is equal to k Em by 2 pi. So, 2 pi del f is equal to k Em. This is obtained by simply calculating 2 pi fi equal to 2 pi fc plus or minus k Em. 2 pi cancel. So, fi is equal to fc plus or minus k Em by 2 pi. So, this comes into picture. So, we all know that omega I is equal to omega c plus instead of k Em, 2 pi del f is substituted. 2 pi del f cos omega mt. And note this as equation 4. Find the instantaneous phase angle also. phi I is equal to integral omega I dt. Omega I is calculated, integrated, which is omega ct plus 2 pi del f plus by omega m sin omega mt plus a constant. So now substitute in the modulated wave of Fm, Ec sin phi I, Ec sin phi I is substituted here. So here you observe that in addition to Ec sin omega ct, I have a Bessel function of del f Ec by Fm sin of sin omega mt. So considering del f by Fm as modulation index of Fm wave, you can represent the expression as E mod equal to Ec sin omega ct plus Fmf sin omega mt. If you expand it, you will get the Bessel function. Cos of mf sin omega mt is this one, j naught of mf plus 2j2 of mf cos 2 omega mt plus 2j4 of mf cos 4 omega mt likewise, and sin of sin gives you the odd terms. So if you expand, you will get various Bessel functions together, which is given by this expression. A naught j naught of mf sin omega ct will be there, plus j1 of mf sin a sin b will be considered as sin omega c plus omega m into t minus sin omega c minus omega m into t. Likewise, various Bessel functions you will be getting. So, if you apply the frequency modulation, the frequency modulated wave will be consisting of infinite number of sidebands. Starting from Fc, Fc plus Fm, Fc minus Fm, Fc plus 2Fm, Fc minus Fm. Likewise, infinite number of sidebands will be there, but the amplitude gets varied. So if you take the ideal frequency, ideal bandwidth of Fm, ideal bandwidth will be infinite. So depending upon the modulation index, del f by Fm, the sidebands also get varied. When the modulation index is 1, that is when the modulation index is 0, that is only carrier component will be there. No sidebands will be there. When it is 0.25, one sideband component, 0.5, two sideband. Likewise, depending upon the modulation index, the number of sideband components gets varied. The Bessel functions is represented like this. Carrier frequency, first sideband at frequency Fc plus Fm, Fc minus Fm. Second sideband Fc plus 2Fm, Fc minus 2Fm. Likewise, those are all mentioned according to the modulation index. Depending upon the modulation index, the number of sidebands gets varied. So, if MF is 0.5, you get 2 sidebands. If it is 1, 3 sideband. If it is 2, 4 sideband. If it is 2.5, 5 sideband. If it is 4, 7 sideband. So, depending upon the modulation index, what happens is that your bandwidth gets varied. When the modulation index is 0, there won't be any sidebands. But when the modulation index increases, the number of sidebands also increases. When the modulation index increases, the carrier component J naught of MF decreases. Whereas for larger value of MF, this JNM of MF decreases rapidly. And you have to make a note that the sidebands are significant only when the amplitude is greater than or equal to 1% of the unmodulated carrier. That is, EM has to be at least greater than or equal to 1% of EC. So, modulation index of Fm is given by del f by Fm, and frequency deviation ratio is given by maximum carrier frequency deviation by maximum message signal frequency. And next one is phase modulation. Phase modulation is nothing but the changing the phase of the carrier in accordance with the instantaneous amplitude of the message signal. So, phase of the carrier signal is varied based upon the message signal. So, when the amplitude is low, the carrier is stretching. So, the phase is getting lagged here. And when the amplitude increases, carrier compression happens, which means that phase is leading here. So, depending upon the amplitude of the message signal, the phase either lags or leads. Lagging is mentioned here by means of stretching. Leading is mentioned here by means of this compression. So, when you compare this frequency and phase modulation signal, here frequency deviation is proportional to message signal's amplitude. Here phase deviation is proportional. Noise immunity is better in FM compared to PM, but here PM's noise immunity is better only compared to AM, not to FM. So FM is superior in case of noise immunity, and SNR is also better in FM compared to PM, and this FM is commercially used in broadcast stations in the range of 88 MHz to 108, whereas PM is used for mobile radio service, and the modulating signal is proportionate to del F and FM. So del F is KEM, whereas here phase modulation, it is proportional to only the modulating signal. And the bandwidth required, general actual bandwidth is 2 into number of sideband components into FM, whereas Carson approximated the rule as 2 into del F plus FM. And as a summary, we have seen about angle modulation schemes. Under angle modulation, we have seen frequency modulation and phase modulation. And finally, we have compared frequency modulation and phase modulation. And we have come to the conclusion that frequency modulation is preferably better compared to phase modulation. And these are the references referred. Thank you.